where, to the Padhai Kar Lo JEE preparation channel, you can practice more problems on this exact topic on our Padhai Kar Lo Android app, link in the description below, or on our website padhaikarlo.com. Today's topic is Coulomb's law, the fundamental force law that governs how electric charges interact with each other. Let's begin. Coulomb's law states that the electrostatic force between two genuinely point charges is directly proportional of their magnets, and inversely proportional to the square of the distance between them, written as F equals K times Q1 Q2 divided by R squared, where K is Coulomb's constant, approximately 9 times 10 to the power 9 Newton meter squared per Coulomb squared, and this constant can also genuinely be written as 1 over 4 pi epsilon naught, where epsilon naught is the permittivity of free space. This force genuinely acts along the straight line joining the two charges. It's attractive if the two charges have opposite signs, and repulsive if the two charges have the exact same sign directly mirroring, yet fundamentally distinct from Newton's law of gravitation in its inverse square mathematical form. Written more completely in vector form, the force on charge Q1 due to charge Q2 is F equals K Q1 Q2 over R squared times R hat, where R hat is the genuine unit vector pointing from the source charge toward the charge experiencing the force. This vector form correctly captures both the magnitude and the actual direction of the force in a single, unified expression. When more than two charges are genuinely present, the principle of superposition applies directly. The net force on any one specific charge is simply the vector sum of the individual Coulomb forces from every other charge, calculated completely independently and then added together. This superposition principle is exactly why electrostatics problems with multiple charges reduce to careful vector addition rather than requiring any fundamentally new physics. A genuinely classic JEE technique for problems with multiple point charges involves setting up a genuine coordinate system first, resolving each individual Coulomb force into its x and y components, before actually summing them separately. This systematic approach genuinely avoids errors that arise from attempting to add force vectors purely geometrically without a clear, consistent reference frame. A frequently tested trap involves genuinely comparing Coulomb's law with gravitation. Both follow an inverse square law, but the electrostatic force is dramatically stronger than gravity for charged particles, and unlike gravity, which is always attractive, the electrostatic force can genuinely be either attractive or repulsive depending on the specific signs of the two charges involved. Also remember that Coulomb's law, exactly as stated, genuinely only applies directly to point charges or to genuinely spherically symmetric charge distributions, where the distance r can correctly be measured from the actual center. For other irregular charge distributions, a full integration is genuinely required instead. Let's recap. Coulomb's law states uppercase F equals K Q1 Q2 over R squared, with the force acting along the line joining the charges, attractive for opposite signs, and repulsive for the same sign. For multiple charges, the principle of superposition lets you add individual pairwise forces as vectors to find the net force, remembering to resolve forces into components before summing, and that Coulomb's law strictly applies to point charges, are the keys to avoiding common errors. Draw. Keep the inverse square formula and the vector superposition principle sharp. They're the foundation for every electrostatics problem that follows. If this video helped, please like it and subscribe to Padhai Kar Lo for more JEE preparation content just like this. See you in the next one.